let's do another example of a higher order homogeneous differential equation. So here we have the polynomial applied to y. It is d squared minus 1 times d squared plus 5d plus 4 all this squared applied to y equals 0. So the characteristic equation is r squared minus 1 times r squared plus 5r plus 4 squared equals 0. So this is a square difference, so we can put r plus 1 times r minus 1. Here we are going to try to complete the square, so we have r squared, whatever it be, would be square. It is very important that we be careful with the exponents that we have. Well, here we have just 1, here we have square. It is very important that we don't forget it. So would be r squared plus 5r plus, in order to have a perfect square, I would need to have half of this is 5 halves, square is 25 over 4. So if I'm adding a 25 over 4, I will need to subtract it later. So first plus 4 and then minus 25 over 4. So r plus 1 times r minus 1 times r plus 5 halves square plus, this is 16 over 4 minus 25 over 4 is minus 9 over 4 square equals 0. So this is r plus 1 times r minus 1 times, this is a square difference. It would be, well, first square, everything square, would be r plus 5 halves minus root of this is 3 halves times r plus 5 halves, well, here plus 3 halves and here minus 3 halves. So it is r plus 1 times r minus 1 times, this is 8 halves, so it's r plus 4 times r plus 2 halves, so r plus 1, all this is square equals 0. So it would be r plus 1 times r minus 1 times, I could say this square times this square, so r plus 4 square times r plus 1 square equals 0. So I have this and this would be, well, I could put it as r plus 1 times r plus 1 times r plus 1. This is in order to see it clear, the solution. When we have practice, we could do it faster and we don't need to write all this, but let's write it this time. It would be r plus 1 times r plus 1 times r plus 1 because of this, times r minus 1 times r plus 4 times r plus 4 equals 0. So the roots are r equals to minus 1 3 times r equals 1 just 1 time, and r equals to minus 4 2 times. So the solution would be y equals to, let's put this one first, so it's c1 e to the x plus c2 e to the minus x plus c3, again I will take the other root, that is r equals to minus 1, but so I need to add r, so it would be c3 x e to the minus x. I have another one, so it would be plus c4 x squared e to the minus x, and now just two of these, I will continue here, plus c4 C5 e to the minus 4x plus another of this is C6x e to the minus 4x. Or in order to put it more reduced, we can say y is equal to C1 e to the x plus, I will factorize the e to the minus x, so I have C2 plus C3x plus C4x squared, C2 plus C3x plus C4x squared times e to the minus x, and this same with this, plus C5 plus C6x e to the minus 4x. So this is the solution to this higher order homogeneous differential equation. See you in next video.